Forward arming and refueling points, better known as FARPs, are temporary, rapidly established sites that allow helicopters and tilt-rotor aircraft to refuel closer to where they operate, instead of flying all the way back to a main base. They are simple in appearance but critical in function. A FARP can be set up on a strip of open ground, a cleared field, or a remote landing zone. With just a small team and portable equipment, it becomes a refueling hub that keeps aircraft flying longer, farther, and with less downtime. In this episode, we're going inside that process. We will look at how a FARP is built from the ground up, how the fuel system is laid out and tested, and how the refueling phase is carried out safely and efficiently while engines are still running. We will not focus on the aircraft in flight. Instead, we will concentrate on the part that is usually unseen: the ground crews, the hoses, the pumps, the safety checks, and the procedures that make forward refueling possible. Building a forward arming and refueling point begins long before any aircraft touchdown. For the ground team, the site itself is the first mission. Before a single hose is unrolled or a generator is started, they must understand exactly what kind of environment they are working in and how it will affect both safety and efficiency. The team surveys the area and evaluates the terrain. Is the ground firm enough to support repeated landings? Is there vegetation that could interfere with rotor wash? Where will dust accumulate? And how will wind direction affect visibility? FARP locations are chosen not for comfort, but for practicality. If the site offers good access and safe approaches from multiple directions, it becomes a viable candidate. Once the layout is decided, the ground team begins shaping the site into a functioning refueling point. Fuel containers are positioned first. They must sit on stable ground, away from potential hazards and clear of rotor paths. Next come the pumps and power units, placed where operators can reach controls quickly without obstructing aircraft movement. One of the earliest and most important tasks is grounding the system. Grounding rods are driven into the soil to create a safe discharge path for static electricity. Even a small spark, unnoticed by the eye, can become a serious risk during refueling. So before fuel flows, every piece of equipment, lines, pumps, nozzles, and the aircraft itself, must be properly grounded. With the grounding system in place, attention shifts to the fuel lines. Hoses are unrolled in long, measured stretches, positioned so they do not twist, bend, or create tripping hazards. Each connection is inspected closely. Couplings are tightened, seals examined, and valves checked for both movement and resistance. Operators test flow the system with the valve closed to confirm pressure integrity. It is a slow and methodical process, but every step has a purpose.
Yeah, this one's fine. This one had gasket.
Parallel to this, another part of the team marks out the landing zone. Cones and visual markers define where aircraft will touch down, how they will move, and where ground personnel must stand during operations. These markings help maintain predictable movement, which is essential when multiple aircraft may arrive in sequence. Team members also establish a perimeter around the site. This perimeter is not about defense. It is about safety and control. It ensures that only trained personnel enter the active refueling area and that equipment remains undisturbed. It also allows supervisors to oversee operations from locations where they can clearly observe hose lines, pumps, and aircraft approaches. Once all components are in place, grounding, pumps, hoses, and visual markers, the system must be tested. Operators activate the pump and simulate fuel flow through the lines. They monitor pressure, listen for irregular vibrations, and check each connection point for stability and leaks. If something is loose or misaligned, this is when issues must be caught, not when an aircraft is already waiting on the ground. When the test confirms that everything is operational, the FARP transitions from a setup stage to readiness. What was once an empty patch of land is now a fully functional refueling point, capable of supporting rotary and tiltrotor aircraft under demanding time constraints. This preparation phase is the unseen backbone of every FARP mission. If the setup is done correctly, refueling will be safe, fast, and predictable. If even one step is rushed or skipped, operations can slow down or stop entirely. In the field, precision matters. And the precision begins here, long before any aircraft arrive. Once the forward arming and refueling point is fully established, the mission shifts from preparation to execution. This phase, refueling, represents the core purpose of the FARP. Every movement from this moment onward is shaped by a commitment to safety, consistency, and efficiency. The process begins the moment an aircraft comes to a full stop. Engines often remain running, which means noise levels are high, and rotor wash continues to move dust and debris around the site. For this reason, fueling teams approach cautiously, staying within designated paths and maintaining visual contact with each other. The first task is grounding the aircraft. A grounding cable is attached to a secure point on the airframe to neutralize static electricity. Even a small static discharge can be dangerous when working with fuel, so grounding is always performed before any hose makes contact with the aircraft. With the aircraft grounded, the fuel team brings the hose forward. The nozzle operator ensures the hose is aligned properly, avoiding twists or tension that could reduce flow efficiency. Before connecting, the operator inspects the fuel port visually, looking for debris, damage, or signs of contamination. The nozzle is then locked into place using a secure coupling mechanism. This seal must be firm, as the fuel will soon be moving under pressure. After attaching the nozzle, the operator performs a brief pull test to confirm the connection is stable and leak-free. Once the hose is secured, the pump operator begins preparing the system. They check the fuel pressure gauge, ensuring the value is within the safe operating range. Communication during this stage is deliberate and minimal, mostly visual signals and short confirmations, because the noise from the aircraft requires concise coordination. When all operators give the ready signal, the pump engages. Fuel begins flowing through the hose, and the system immediately enters the monitoring phase. One member watches the pressure gauge, noting any fluctuations. Another focuses on the hose line, checking for movement, vibration, or early signs of a leak. The nozzle operator remains near the connection point, monitoring for drips or unexpected changes in flow. Refueling is not simply about transferring fuel. It is about controlling risk. Any irregularity in sound, pressure, or fluid behavior prompts an immediate pause. Operators are trained to react instantly, because even minor issues can escalate rapidly in a high-energy environment. As fuel flows into the aircraft, time becomes a critical factor. The goal of a FARP is to minimize the aircraft's time on the ground. This allows air operations to continue seamlessly, supporting missions that may rely on continuous aerial presence Efficient refueling ensures the aircraft can return to the mission loop quickly, maintaining momentum across the entire operation. Throughout the process, the ground team maintains strict awareness of their surroundings. They remain clear of rotor paths, avoid unnecessary movement, and communicate through standardized hand signals. This environment is fast-paced, but never rushed. Precision overrides speed, and discipline overrides routine. Once the fuel load is complete, the pump operator shuts down the flow gradually, monitoring the pressure as it returns to zero. The nozzle operator waits until the hose depressurizes fully before unlocking the coupling. This prevents sudden release of residual fuel and ensures safer disconnection. After the nozzle is removed, it is wiped clean to prevent dripping. Ground personnel inspect the hose and the area beneath the aircraft for any signs of leakage. Only when the final check is complete do they signal that the fueling operation is finished. The hose is then carried back along the designated path, coiled or staged for the next aircraft. Grounding lines are removed last, ensuring the aircraft remains static safe until all fueling components are clear. Though a single refuel may take only a few minutes, it is a tightly controlled process, shaped by training, repetition, and constant situational awareness. It is here, in these few minutes, that the true purpose of the FARP is realized. Rapid, safe, and reliable support that keeps air operations moving. In forward environments, this capability is essential. A well-run FARP extends the operational range of aviation units, reduces response times, and supports sustained missions without the need for traditional airfield infrastructure. It is a small footprint with a large impact, and every successful refuel reflects the precision of the team behind it. Forward. Arming and refueling points are often considered one of the most understated components of aviation operations. They rarely appear in the spotlight, and for most viewers they remain almost invisible. Small patches of ground, where crews work quietly, precisely, and without interruption. Yet the impact of a FARP is felt across every mission that relies on aircraft speed and endurance. When a FARP is active, aircraft no longer need to return to main bases for support. Instead, they can land closer to where they operate, receive fuel rapidly, and return to the air within minutes. This greatly reduces flight time, shortens the turnaround cycle, and increases the number of aircraft that can support an operation within a given time frame. The importance of this capability becomes clear when considering the nature of modern missions. Aviation assets often need to maintain presence over wide areas, respond quickly to emerging tasks, or support ground elements operating in remote locations. Without a forward refueling point, response time grows, fuel consumption increases, and operational tempo slows down. FARPs solve these challenges by offering mobility. Unlike fixed airfields, they can be established in different terrains: open fields, rugged clearings, shoreline flats, or temporary landing zones prepared specifically for the operation. This flexibility allows aviation forces to adapt quickly to changing conditions. Behind every FARP is a team trained to work in demanding environments. Their job may not be as visible as that of pilots or air crews, but their contribution is fundamental. They operate pumps, manage fuel lines, maintain safety procedures, and coordinate aircraft movement, all while working close to running engines, loud rotor wash, and constantly changing conditions. Across the operation, communication remains the backbone of safety. Even though we did not focus on radio procedures in this episode, silent coordination, hand signals, visual checks, and deliberate timing shapes everything that happens on the ground. Every member of the team must understand not only their own role, but the roles of those around them. Refueling also requires continuous monitoring of environmental factors. Dust, wind, temperature, and terrain can influence how quickly fuel is delivered and how safely the team can operate. Even small changes on the ground require adjustments in procedure. When the refueling process concludes, the aircraft lifts off again, leaving behind only the quiet hum of equipment and the steady rhythm of the pump winding down. For the ground crew, however, the work does not end. Equipment must be inspected once more, lines must be checked, and the site must remain ready for the next aircraft. A FARP is rarely active for just a single mission. It often supports a sequence of flights, each depending on the efficiency of the team on the ground. Over time, it becomes clear that forward refueling is not simply a logistical task. It is a capability that shapes the entire operational landscape. It extends range, supports mobility, and ensures continuity in missions where timing and endurance are critical. By maintaining this capability, aviation forces ensure they can operate where they are needed most, not just where infrastructure exists. And while the FARP itself may be temporary, the effect it has on operational readiness is lasting. In future episodes, we'll explore what happens once the aircraft leave the ground, how crews navigate, coordinate, and carry out their missions in the air. We will also look deeper into the equipment, the procedures, and the people who support aviation operations across different environments. For now, this concludes our look inside the forward arming and refueling point, the place where mobility begins, where missions restart, and where every drop of fuel moves operations forward. This is the unseen work behind every successful flight. This is how the mission continues. Wishing you a good day wherever you are. Stay safe, stay curious, and see you in the next episode.